Welcome back. In this video, we are going to solve problem 14-12 that is taken from chapter 14 Energy Methods and book name is Mechanics of Material by R.C. Hibbeler. So statement is if P is 10 kip, determine the total strain energy stored in truss. Each member has a diameter of 2 inch and is made of A992 steel. So you can see this is truss clear and there is a load of P which is given as 10 kips. The diameter of each member, which is DAB, DABC, CD, and each diameter is 2 inch. Clear? And due to this load in truss, you have to find the total strain energy stored in that truss. And we know that truss carries only axial load. So strain energy UI due to axial loading will be equal to sum of F square or N square L divided by 2AE, where A is axial load that is carried by member, L is length, A is area, and E is modulus of elasticity. So based on, you can see this is a member AD, this is member CD, this is BC, this is AB, and this is DB. So this formula will become, if you expand it, it will become equal to FAB square into LAB divided by 2 area of AB into E plus FBC square into LBC divided by 2 times area BC into E plus FCD square into LCD divided by 2ACD into E plus F square AD into LAD divided by 2AAD into E plus FBD square LBD divided by 2 times ABD into E. So what we are going to do is that we will find these forces in each member of the truss. The length is also given, some is given, and some we will find it, and we will find the area as well. So let's start with the solution. So what we will do is that we will apply method of joint, and we will take joint B first, and you can see that due to this load, this CD will be in tension, this AB will be in tension, and this BC will be also in tension because it will cause elongation in this length, and this will be like this. Clear? So you can see this as a result, this member will exert load on point B like this will exert load like this, and this will be like this. So we will draw the free body diagram. This is your point B. Clear? Where you have P load which is acting downward, and that P is equal to 10 kips. Clear? This member BC will exert load on point B or joint B like this. This will be equal to FBC. This member AB will exert force like this. This will be equal to FAB, and this BD will exert force in upward direction. So now we will apply equation of equilibrium in order to find these forces. So first equation of equilibrium is that sum of all forces along x direction must be equal to 0, and force toward right side is taken as positive. So FBC is in right direction, so FBC minus FAB will be equal to 0. So from here we can say that this FBC is equal to FAB. Clear? And this will be our equation number 1. Now what we are going to do is that we will take another joint, and that will be joint D. Now you can see this is joint D. So this member will exert, as it is elongating due to this load, so this member will exert force in this direction. Clear? And these two members will exert force in this direction at point D. So we will take this joint D. This is your joint, this is your point D, where you have this F sorry, this will be FBD. Clear? This will be FBD. Okay. So this at this point you will be having FAD, FAD, and this another component will be FCD, FCD. Now you can see this is making horizontally theta. This is also theta. So you can see this is theta and this will be also theta. Clear? So we will find these forces by using equation of equilibrium. So first equation of equilibrium is that sum of all forces along x direction must be equal to 0 and force toward right direction is taken as positive. So this FAD will have two components. Horizontal component will be this one, which will be equal to FAD cos theta, and similarly this FCD will have one component horizontally toward negative toward left side, and this will be equal to FCD cos theta. Clear? So, and there will be vertical component of this, and this vertical component will be this one, and similarly the vertical component of FBD will be this one. So this component will be equal to FAD sine theta, and this component will be FCD sine theta. So you can apply equation of equilibrium. So you can see two forces horizontally acting. One is this one and another is this one. So I will write it FAD cos theta minus FCD cos theta is equal to 0. So FAD cos theta will be equal to FCD cos theta. Cos theta will cancel and we will get FAD is equal to FCD. Clear? Now we will apply another equation of equilibrium, that is sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see now three forces. One is this one, the second one is this one, and third one is this FBD. Their sum must be equal to 0. So I will write it FAD sine theta plus FCD sine theta minus FBD is equal to 0. So you can see FAD and is equal to FCD. So FAD sine of theta plus FCD is equal to FAD. So I will write it as FAD sine of theta minus FBD is equal to 0. So 2 times FAD sine theta is equal to FBD. Clear? And we will get FAD will be equal to FBD divided by 2 sine of theta. Now we will again go back to joint B and we will apply another equation of equilibrium, that is sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So you can see one force is FABD which is upward and the second one is 10 kips downward. Their sum must be equal to 0. So FBD minus 10 is equal to 0. So from here you will get FBD will be equal to 10 kip. Okay, so what we will do is that we will put this value of FABD over here and the sine theta value as well. So if you take sine theta will be equal to perpendicular, and perpendicular is this 4. Clear? So 4 divided by the hypotenuse, and the hypotenuse is not known. So you can see this is 3, this is 4. So hypotenuse will be equal to 3 square plus 4 square under the root, and that will be equal to 5. Okay, that will be 5 feet. So 4 over 5. So now put this value over here. So FAD will be equal to FBD is 10. So 10 divided by 2 multiplied by sine of theta is 4 by 5. 4 divided by 5, and that will be equal to 50 divided by 8, which is equal to 6.25 kip. Okay, Since FAD is equal to FCD, so what we get is that FAD is equal to FCD, and that is equal to 6.25 kip. Okay. So let's go back. This is FAD, this is FCD. And due to this load, these two members will be in compression. So I will write it over here, compression. And this FBD will be in tension. How? Let me show you. You can see due to this load, this member BD will be in tension. Okay. Now we have this FBC is equal to FB3. Okay. Now we will apply method of joint at joint C. So you can see here you will be having one load that will be one will be the reaction force, which will be Cy, and this will apply load in this direction, and this member will apply load in this direction. Because you can see due to this load, this will be in tension. As a result, this will exert force at point C in this direction, and this member will exert load in this direction. Clear? So we will draw the free body diagram at joint C. So I will write joint C. So let this is your joint C. Clear? Where you have vertical reaction of roller support Cy. The force exerted by BC will be this FBC. Clear? And you will be having FCD, which we have calculated, that is 6.25 kip. Clear? Okay. If you look at this angle is theta. Clear? So I will write here, this is the angle, horizontal angle is theta. Clear? And we will apply equation of equilibrium. So first equation of equilibrium is that sum of all forces along x direction must be equal to 0, and force in this direction is taken as positive. So one force, which is FBC, is in opposite direction. So I will write minus FBC plus it will have two components. One is vertical and another is horizontal. So this component will be equal to plus 6.25 cos of theta is equal to 0. And we know that cos of theta here is equal to base over hypotenuse. So base is 3 and hypotenuse is 5. So 3 by 5. So I will write 6.25 into 3 by 5 will be equal to FBC. And FBC, you can see that FBC is not known. So 6.25 multiplied by 3 by 5 will give you 3.75 kip, and that will be FBC. So I will write it, FBC will be equal to 3.75 kip. Okay. Now we know that FBC is equal to FAB. So from here, FAB will be also equal to 3.75 kips. And these two loads, both loads will be in tension. This FBC and this is FBC and this is FAB. They will be both in tension. So now we have all the values. We are going to find area since diameter is same. So diameter is equal to pi by 4 d square. All the diameters are same. You can see this is, let this will be equal to d. So area will be equal to pi by 4 d square, and that diameter is 2 inch. So by pi by 4, 2 square will give you pi, and unit will be inch square. Clear? And length of all is known. Clear? So this AB length is 3 feet, this is 3 feet, this is 5 feet, this is 5 feet, and this is 4 feet. So you can easily now put the value in each in this table. We will need E, modulus of elasticity of A992. So for that we will go to the property table of the book. So you can see this is the property table, and A992 E is 29 into 10 raised to power 3 KSI. So we will note down it as well. E is equal to 29 into 10 raised to power 3 KSI. So what we are going to do, we will put the value in the formula. UI due to axial load is equal to, this is the formula. Let me copy it so that we can easily put the value. Okay, we'll copy it and we will paste it over here. This was the formula. Clear? So what we are going to do, FAB. So FAB, we will look FAB. FAB is this one, 3.75. So 3 point, we will take the 1 over 2 AE common. 2 AE common. There, and we will left FAB 3.75. 3.75 square, and we will multiply it with 3.75 LAB, length of AB, which is 3 feet. So in inch, it will be 3 into 12. Clear? Plus, we have done with this FBC. FBC is 3.75 and length is also same, 3 into 12. Let me show you. FBC is 3 feet. Okay. Plus, this is square. FCD is, you can see this is 6.25. So 6.25 square multiplied by length of CD. CD is 5. This is hypotenuse 5. So 5 multiplied by 12. Why 12? We are converting feet into inch. Clear? Plus FAD. FAD is also 6.25. So 6.25 square multiplied by length will be also 5 multiplied by 12. Let me show you FAD. This is also 5. We will left only BD, which is 4, plus BD, FBD. FBD is this one, 10 kips. So I will write 10 square multiplied by 4 multiplied by 12. Clear? And we will also write it as 1 over 2. Area is pi and E is 29 into 10 raised to power 3. Multiply by all these values. I will copy it and I will paste it over here. Clear? Okay. Now, when you solve this, you will get strain energy due to axial loading will be equal to 0.0576 kip into inch. So this is the amount of energy that will be stored in this truss. So, but before that, we will check it whether it's fail or not. So you can see here from this, you can see the maximum load is 10 kips. All other values are less. This is less, this is less. So maximum value is 10 kips. So what we are going to do is that we have FBD is maximum. Clear? And that is 10 kips. So stress, maximum stress will be equal to force per unit area. So 10 kips divided by area is pi inch square. Clear? So that will give you 3.18 KSI. So this maximum stress should be less than yield strength of A992, and we will check yield strength of A992. So what we will do is that we will move toward same property table, and you can see that A992 will have yield strength of 50 KSI. Okay. I don't know why my pen is not working, but you can see in the row this is 50 KSI. So I will write it 50 KSI. So you can see 3.18 KSI is less than 50 ksi, so it means that it will not fail clear, and the amount of energy stored by the truss is 0.0576 kip. And that was all about this problem 14-12. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching, and also don't forget to share my video in your circle and help me in growing my channel further.